Welcome friends. Today I am going to discuss on quality assessment of GPS surveying. As you know that during GPS surveying we do collect GPS observables which is being processed to get the position of points and baseline. Now the position what we have derived out of GPS observable and the baselines that we have got from GPS observable, whether that is meeting our specification or not. That means whether these parameters has achieved the standards that we are looking for the particular project or not, that has to be assessed, and that assessment is called quality assessment. Now in order to assess that quality, we need to know first what are the different standards that we follow for GPS surveying. Then on the basis of the standard, then we have to compute some measures which will be tested on the basis of standards to find out the quality or standard of the GPS surveying. So in this class we will be talking on first we will talk on the standards of GPS surveying and followed by the quality measures that we will compute to identify the standard of our surveying or quality of our surveying. Now the standard of GPS surveying is being defined by the root mean square error for position, and it is the parts per million for the baseline. So GPS standard for GPS surveying is defined for position and baseline length, and the position is defined by root mean square error and length by parts per million. Now these standards may vary from organization to organization, from country to country. There is as such no such unified standard available all over the world, but generally we consider the standard defined by FGCS, Federal Geodetic Control Subcommittee. This is an organization that is available in US. So their standard we are considering in GPS surveying as a standard. Now the FGCS has defined the position standard in terms of root mean square error as it is written, that is they have defined the horizontal and vertical. Actually the position may be planimetric. For planimetric position we do go for horizontal standards and maybe independently vertical, or we may sometimes go together as the 3D position. Now FGCS has taken 95% confidence level. Now what is this? Actually if we know this is the position, true position, then the observed position should be 95% within the standard that has been defined. Suppose we have defined that now for FGCS, for the planimetric they have defined an error ellipse radius of an error circle or ellipse, error circle, let us say when the component in x and y are same. So, now suppose this is the true position of any point. Now, and if suppose 1 meter is the error, permissible error, radius of the error circle is 1 meter. So, if we draw a circle of 1 meter around the true position P, then the observed position in 95% cases should be within this circle. Then we will say that this set of observation follows the standard which we are looking for. Now, in case of vertical, we do define a line, uncertainty line. So, plus minus this. So, with this, the 3D, for 3D we define a cylinder. Suppose this is the point. So, around this point this is the error ellipse and this is the height uncertainty. So, we will get a cylinder like this. That means, if our true position is this, then we will the set of observation of which 95% lies within this cylinder, then we will say that that set of observation has met the standard as required by our project. Let us, for example, for our project horizontal accuracy we are looking for suppose 1 meter planimetric accuracy, and vertical accuracy suppose also we are looking for 1 meter. So, in these cases we will have a cylinder having this radius 1 meter and your 1 meter above and 1 meter below this line. So, we will have a cylinder having height of 2 meter and radius of 1 meter. Now, if we have a set of measurement which if we see that all of them are within this, at least 95% of them are within this cylinder, then that set of observation are meeting these criteria. If less than 95% are not within this, if less than 95% is within this, then we will say that the set of observation is not followed our standard. So, we will be need to take better set of observation, so that condition met by this to satisfy our standard. So, that is about the positioning standard. So, and as per this FGCS consideration, so FGCS positioning standards, so which is considered to be at 95% confidence level, and for planimetric position the position we considered at the datum surface position. And for height may be orthometric height, that means height above geoid, or it may be ellipsoid height. So, height above, when height, it is height above datum surface. Under this consideration, the FGCS has defined 4 categories of millimeter standard, centimeter standard, decimeter standard and meter standard. So, out of this again they have decided to have 3 under millimeter, 1 millimeter, 2 millimeter, 5 millimeter. Like that you can see here that centimeter 1, 2 and 5 centimeter, decimeter again 1, 2 and 5 centimeter, and meter 1 meter, 2 meter, 5 meter and 10 meter. So, centimeter again 1, 2, 5 centimeter, decimeter again 1, 2, 5, and but in meter it is 1, 2, 5, 10 meter. So, this is the way how they have given the standard. This is what for the point position. Next, for baseline. For baseline, the standard has been defined. Standard has been defined parts per million. Now, how it is been we got it is the error permissible divided by the length of baseline. So, this is the value which we have to get, and we have to see this value is what is amount, and that should be compared with the standard. Again FGCS has defined 7 standards and they had termed it as order, like AA order, then A order, B order, C1, C2 1, C2 2, then C3. So, now each of these having the parts per million as given in the table, that 0.01 parts per million, or we can say 1:2 Similarly, if we say this is the parts per million as a fraction, there is 1:2. Like this we can get all the detail here in this table. Now, what is this actually? Let me explain. That means, if the baseline is order AA, then we will allow an error of 1 millimeter in measuring a distance of 1,000,000 millimeter. So, in measuring a distance of this millimeter, we will allow an error of 1 millimeter. Now, this is means 100 kilometer. So, if we measure a baseline of having length 100 kilometer, and if we end up with a solution which provides an error of 1 millimeter, that means our measurement length can be plus minus 1 millimeter. So, the measured distance between the two stations, if the actual distance between the two stations A and B 100 kilometer, the distance between A and B is 100 kilometer, that is the true distance. if we measure the distance between A and B and we get the distance measured 100 kilometer plus minus 1 millimeter, D is equal to this. That means DAB, D measured AB should be so if we get this thing, the measured distance is equal to or more than this or equal to or less than this, then we will say that our measurement is of the order of A. So, or the baseline we got is A order. Similarly for other orders, so here we can see 1 is to 10,000 C3, which provides an error of 100 parts per million. That means if we measure a distance of 10 meter, we may allow an error of 1 millimeter. In measuring a distance of 10 meter, we are allowing an error in measurement of 1 millimeter. That is what is called C3. Now, with this background of with the standard of GPS surveying, now we want to find out what is the quality of our GPS surveying. So, in order to do that, we need to know two parameters. One is called precision, another is called accuracy. Now, if we have the true value of the position or the length of the baseline, then we can go for accuracy measurement. But if we do not have the actual value of the position or the length of the baseline, then we should go for precision. Now, in case of position, the precision we do test by using the t-test, and that will depend upon number of observation. If it is less than 30 or more than 30, depending upon that we should follow this relation that t 0.025 square root of n square root of sigma x square plus sigma y square t, this is minus when n is less than 30. The meaning is that now sigma x and sigma y are the standard deviation of the measurements. Suppose we have taken n measurements which is less than 30. So, for all these measurements we will get the mean and standard deviation. So, sigma x and mean in y direction, sigma y. So, this sigma x and this sigma y is this, and square of and square, that is root mean square error. So, this is root mean square error of the observed data, and that should lie within this. So, if the observation satisfy this condition, then we will go for test of this with standards. Now, we will see what is the value of this square plus what is this value of this. Now, if it is, suppose we have this thing as 5 centimeter, then as per our previous definition that it will be under the category of 5 centimeter. So, we can say that this is our accuracy, or this is the standard of this. So, depending upon this value we will be telling it that, but before that we have to satisfy this. Similar to this, if the number of observation is more than 30, then we have to use this formula. Now for this is for 2 dimensional case. Now if we see, if we want to find out the 3D position, so instead of this we have to take the root mean square error of x, y and z. So this is the root mean square error of x, y, z position of the observed location, and we have to see this test same what we done. So in this way, first we have to see that we should test first the precision whether it satisfies the fundamental criteria, then we can categorize it to the category of a standard. Now in case of baseline, we do find out the value sigma x square, sigma y square, sigma z square. Now as we know that when we go for GPS surveying for a baseline, so we will get del x, del y, del z, that means if it is the reference, this is the rover, with respect to rover about this baseline we will get, along with that we will get so these are the standard deviation of the parameter del x, del y, del z with respect to baseline, with respect to baseline. So in case of baseline, we have to take the ratio of this and square root of del x, del y, del z. So this will provide us some value 1:something, some value, that means, and that we have to convert it in terms of parts per million, and this we have to check with the standard that is there with this, and depending upon this value we can say which order baseline is this one. So this is on the basis of precision measurement of the baseline. As I told you that accuracy measures we will be taking when we will know the true values of the position of the point. Suppose a point is having xt, yt, zt is the known point. Now and the observed value for that is x bar, y bar, z bar. Then we will have xt minus x bar square, yt minus y bar square, zt minus z bar square, square root, that is the root mean square error of the point. Now we have to see what is the value of this with the, now for this is the 3D position. So and for 2D position it will be this is for only x direction, this is for y direction, this is for z direction. So we call it root mean square error x, this is this part xt minus x bar whole square. Similarly root mean square error yt minus y bar square, like this. Now there may be defined condition. So in some cases we may assume, we may allow in our work root mean square error in x direction should be equal to root mean square error in y direction, then it is the circular error. In that case the amount of error root mean square error will be equal to 1.4142 root mean square error in x direction or in y direction. So ultimately it is the radius of the circle which is defining the error circle. That means now this value, now we have to see what is this value. Depending upon this value, suppose it is 2 centimeter, then from our chart we can say 2 centimeter means this is the our standard of our measurement. So in this way we can compute we can see what is the standard of our GPS surveying. Now if it is this value, this is the root mean square of z, suppose this is 3 centimeter, then we can say that 3D standard is 3 centimeter. If this is value is 2 centimeter, then we can say planimetric standard is 2 centimeter. In this way, by comparing this table and computing in this way, we can say what is the standard of GPS surveying. For baseline, suppose we know this is the component of the baseline and true component along x direction, true component along y direction, true component along z direction, and suppose del x, del y, del z are the observed component. Now from this we will be getting L estimated, which will be equal to del x square plus del y square plus del z square, and this is the true L length true, which is del x tree del y tree. Now this L true minus L estimated is the error in observed length, and this error divided by L true provides us the value 1:, how much, and that is to be compared with the standard table to know what is the standard of our baseline measurement. So in this way, how we can get the standard of our survey work, and if we find that the standard that we have found after measurement is meeting the specification of our GPS surveying project objective has been achieved. Otherwise, if the project objective has not been achieved, that means if the standard that we have found is less than what we are looking for our project, then we have to repeat whole our surveying work, we have to improve our measurement to achieve the standard which project demands. So in this way, actually baseline can be analyzed in two different ways. One is called fixed baseline analysis, another is called repeat baseline analysis. In fixed baseline analysis, only one baseline, a single baseline we will take on once and we will do this analysis. In repeat baseline analysis, we will take observation of the same baseline repeatedly for 2-3 times, and then we will go for this type of estimation and we will see whether our baseline standard is meeting the project objective or not. With this I want to conclude, but before conclusion I want to summarize that the GPS surveying parameters should be assessed in order to find whether our GPS surveying meet the objective of the project demand or not. To test the quality of GPS surveying parameters, that is basically the position and the baseline, we need to first know the basic standards that is available. In general, that is varies from place to place or organization to organization. However, the FGCS standards may be taken as the general standard. In order to and the FGCS has considered the 95% confidence level as the basis for its standard, and for point position it is the root mean square error, and for the baseline it is the parts per million, which is been taken as the standard to define the standards. And to test the quality of GPS surveying, we need to measure the precision or accuracy depending upon the availability of the true value or not, and that has to be compared with the standards that is being defined, and from their comparison we will be able to judge whether the GPS surveying has met the quality that is looking for the particular project. We will be meeting in the next class, which will be on procedure for GPS surveying, first part. Thank you very much.